Okay, so today we'll be doing chapter 8. So chapter 8, first things, well, since we have gone through for all these notes already in a lecture yesterday, so today I'm just going to focus on one thing, which is how to determine the directions for thought. Okay, so in this chapter, we have four subtopics. First subtopic is about the terms that you need to know. Okay, all these angular accelerations, angular velocity, and angular displacement. And then second subtopic, okay, we have a new terms called torque. So torque is the main focus for today's lesson. We are going to see how to calculate torque. Okay, so torque is a vector product between distance and of a force and the distance from the rotation's axis. Okay, so the force and the distance from the rotation axis, that is what we need to include in our calculations. So torque equals to R cross F. So you must know R cross F is equals to RF sine theta. So rather than cos, now we use sine theta. Okay, so if you look at this diagram, so R is the distance from the rotation's axis. So rotation axis, this is the point, okay, which is the pivot point. Okay, where you near the object is not moving, it's definitely not moving at that position. And then we have a point of action. So point of action is a point where you exerted the force, okay, where the force is being exerted. So that is what we call point of action. So between pivot point and point of action, that is our R. And then, okay, what I want you to take notes is the sign conventions of torque. That would be the things that we're going to use today. So positive, it is positive if the force is anti-clockwise. Okay, and it is negative if the force is clockwise. So this is for when the object is in equilibrium. Okay, just like your force, the chapter 4. Chapter 4, we say right hand side positive, left hand side negative. Upwards positive, downward negative. In this chapter, we say anti-clockwise positive and then a clockwise negative. All right, so now let's see how are we going to apply these two statements in our calculations. So, what I want you to see, okay, I want you to look at exercise 4 and questions number 3. We're going to solve these questions together. Okay, we're going to solve these questions together. And then, now let's see. A uniform ladder AB of length 10 meters. So the length of this whole ladder is 10 meter. And then the mass is 5 kg. It leans against a smooth wall as shown in the figure. The height of the end A of ladder is 8 meter from rough floor. So now this is your A. So from A to floor, it tells you this is 8 meter. Okay. Yeah, this is 8 meter. All right. And then the length of A to B, this is 10 meter. So we have 8 meter and 10 meter right here. So that is the reasons why questions give you these two length. All right. So first, determines the horizontal and the vertical forces the floor exerted on the end of a B of the ladder. So how are we going to sketch free body diagram? Now, when it comes to chapter 8, the free body diagram is not really very free, you know. You can draw the shape of the object. It's unlike chapter 4 where we use single point to represent the object. In chapter 8, you can still draw this rod-like object. Okay, so this is our free body diagram. Why? Because it's involve rotation. Okay, it involve rotations, you need a rod-like object. You cannot just use a single point to represent it. So first, now we have the object. We are going to sketch free body diagram. Now, you look at the questions. The question tells you this ladder, it comes with mass. So ladder is an object. This object, it has a mass that is equivalent to 5 kg. So where should I put this 5 kg? When you have a rod-like object, the locations of the mass, we are going to say that is concentrated at middle, at the midpoint of the length, okay, of the object. So which is here. So it is 5 meter from either end. Okay, it is located at the midpoint. So this is what we call a center of gravity. So this is W of the ladder. Okay, W of the ladder. And then what else do I have? Now I don't have the person standing on it. Now, if you're given a questions where there is a person standing on this ladder, then you need to take into consideration the positions of the weight. Okay, the positions of the weight of this person. But now since we don't have any object lying on the ladder, so this is a very simple questions. Okay, now what should I do next? If you look at the diagram, I have 2 points. Point A and point B, they are touching the other surface. So if they are touching the other surface, now what does it mean? It means they have normal force. So this is my NA, and then here is my NB. Okay, because they are touching the other surface. So I have NA, I have NB. So altogether now I have 3 forces. But if you look at the diagram once again, it tells you have a rough floor. Okay, rough floor means that there is a frictional force. But what is the directions of frictional force? Now, try to ask yourself. If you just leave the ladder lying on the wall, okay, it leans on the wall. If both of the surface, both the wall and the floor, they are smooth, what is going to happen to this ladder? Now, it will slip down. Okay, it will slip down to the right-hand side. So that is the nature of this ladder. If the wall and the floor, both of them, they are smooth. So in that case, in order to prevent it from sliding down, a frictional force need to be added in the opposite direction. Therefore, my frictional force is going to the left-hand side. Okay, it's going to the left-hand side. So this is my free body diagram, all right, with 4 forces in it. Okay, with 4 forces in it. So now, in order to calculate this, the force, okay, now you look at the diagram. Okay, there's an angle between the R and F. If you recall the equations, torque equals to FR sine theta. Theta is the angles between F and R. So if you look at this diagram, okay, there are almost every force, all of the force, it has an angles with the ladder. Okay, it's not perpendicular or parallel to the ladder, but there is an angle between them. So we need the angle. How do we calculate the angles? It's very simple. Let's go back to the original diagram given in the questions. So now we have 10 meter, we have 8 meter, so we can determine the angles at positions B by using trigo functions. So we are given opposite and hypotenuse. So which means we can use a sine. Okay, we can use sine to determine the values of theta here. So sine theta equals to 8 over 10. Okay, 8 over 10. So our theta is then equals to, I think, wait. So a theta is then equals to
53.
53. I think there's 2 decimal places, right? I just can't remember 53.1.
0.13.
All right, thank you very much. 53.13 degree. Okay, so theta is equals to 53.13 degree. So now we have the angles, then we can proceed to calculations. Right? How are we going to do the calculations? When it comes to torque, when something is in equilibrium, okay, we say, okay, now when something is in equilibrium, we discussed it yesterday. What does it mean? It means it is translational equilibrium. Okay, translational equilibrium, which tell us summations fx is equal to 0, summations fy is also equal to 0. And another one is what we say rotational equilibrium. Okay, if rotational equilibrium, then summations torque is equal to 0, which means we need to form a table that consists of all these 3 items. All right, so now let's see how are we going to form the table. So I'm going to draw a table. Okay, so this the first column usually is a force, and then we have a x, we have a y, and the last one is the torque. So this is x component, this is y component, this is summations torque equals to FR sine theta. Now, one thing that you need to remember when it comes to torque, okay, we determine the directions. Okay, this direction, it has nothing to do with x-axis and y-axis. Directions, we determine it by looking at whether it is clockwise or anti-clockwise. Okay, if it is clockwise, then it should be a negative value. If it's anti-clockwise, then it is a positive value. So this is the things that we need to take into considerations when it comes to determining the directions of the torque. Okay, so let's look at the free body diagram that I sketched just now. According to this diagram, now I have a NA, I have a NB, and then I have a W, and I have F in the diagram. All right, so done. That is the things that I need to include in my table. So I'm going to draw an ending line here. Okay, this line is very important. So now we say summations. Okay, summations. Summations, if you look at the conditions in equilibrium, what it tells us is total x, it should be equals to 0, total y should be equals to 0, and total torque is also equals to 0. So in the table, the last column, you can put the summations here, and then you put 0 in all three columns, okay, to remind you that the total of all three columns should be equals to 0. Right? That is the things that we need in our questions. So now let us put the information from the free body diagrams into the table. NA, normal force at point A. Okay, normal force at point A is heading to the right hand side, so definitely it's lying on the x-axis, and it is a positive value because it's going to the right hand side. So x and y, because they represent translational, so you look at, okay, this is a translational. So you look at what happens in the linear motions. Going to the right is positive, left is negative. Up is positive, down is negative. That is for x and y component, all right? So NA is lying on the x component. There's no y components for point A for NA, so y is 0. NB, okay, NB is lying on the vertical component, so its x component is equals to 0. And now it's pointing upwards, therefore I have positive NB. W, okay, W is lying on the vertical component, therefore I don't have an X component. Okay, so this is my W. So W is equals to mg. Okay, mg. So W ladders, this is a W ladder. Okay, I put a subscript here. So a W ladder is equals to the mass of ladder and G. Now, usually when it comes to this type of questions, you will have more than one object. Other than ladder, sometimes they will place items on top of the ladder. So usually I like to put a subscript in a W, okay, to indicate that W belongs to which item. And then the last one is a frictional force. Frictional force is lying on the X component, but now it's going to the left-hand side. So it's negative F. Now, this negative F at the same time is equal to your mu N. Which N? Now, it's located at point B. All right, it is the frictional force exerted exists at point B. Therefore, this should be NB. Okay, it should be NB. So now I have everything for X component and Y component. Let's see what am I going to do for the top. All right, so let me change the color first. So torque equals to FR sine theta. So when it comes to FR sine theta, what should we do? Okay, now you need to choose a point first. You need to choose a rotation axis. Okay, you need to choose rotation axis. But how to choose rotation axis? Now this question, it doesn't give you the pivot point. Alright, dia tak beritahu kamu di manakah dia punya pivot point, where is the fixed position. So let's go back to the questions. So questions A asks us to determine the horizontal and the vertical forces. The floor exists on the end of the ladder B, and then calculate the coefficients of static frictions between the ladder and the floor. So, more things is needed at a point B. All right, more things is needed at a point B. More information need to be calculated at point B. Therefore, we don't choose point B as our pivot point. All right, because you need to calculate coefficients of static friction. You need the values of friction. If you choose point B as your pivot point, then the torque at point B would be equal to 0. Okay, so this question for me, I'm going to choose point A as my rotations axis. So when it comes to equilibrium position and the question doesn't tell you where is the pivot point, it is up to you to choose where is the pivot point. You can choose point A, you can choose point B. Okay, you can choose either point. So for me, I choose point A. Why? Because according to the questions, I need to calculate quite a lot of information about friction. So I need to keep frictions as a variable in my table. Okay, I don't want to remove it from my table. So now let's see. If I choose point A as my rotations axis, that means the torque at point A is equals to 0. Why? Because if you choose pivot point at point A, then it means your R is equals to 0. Okay, R is equals to 0, therefore it gives you torque is equals to 0, because the equation is Fr sine theta. Okay, and then the second thing, NB, point B. Now, point B, the force, of course, you're looking at NB, the force is NB. Okay, so the torque is equals to NB, and then the R now, from rotations axis until point B is 10 meter. So 10 meter sine, okay, now what is the angle? If theta is 53.13 degree, it means the other side would be 36.87 degree. Okay, so this one will be 36.87 degree. So sine 36.87 degree. Now the next questions would be, this torque is a positive or a negative torque? So let's see. So this is my pivot point A, and then this is my ladder. If I pull the object at point B at the positions of NB, and I remove all the other forces, okay, I put a near at point A, and then I pull it towards the directions of NB, what is going to happen? This ladder, it will rotate in the anti-clockwise direction. Okay, you look at the bottom right corner here. Okay, I sketch a diagram here. So you have a straight line which represents the ladder. Imagine you remove all the other forces, and then you just keep NB in our system. Okay, and you pull it. If you pull NB upwards, what is going to happen? The ladder will rotate in the anti-clockwise direction. So this torque is a positive torque. Okay, this torque is a positive torque. So done. So we are done with NB. Now let's see. Okay, let's see for the next one, what are we going to do? So again, next one, you look at the force. The force is known as WL. So I have WL here. And then the distance is R, which is 5 meter. If you look at the diagram, the blue color label. So WL from point A is 5 meter. Therefore, bracket 5. This is our R. And then sine, okay, what is the angles between the ladder and the force? Okay, you look at the diagram. So this position. So if you look at this one, WL and F is actually forming a right angle triangle. Okay, if theta beside frictional force, theta for frictional force is 53.13, then for WL is once again 36.87 degree. Okay, 36.87 degree. And now it is a positive or a negative value. Okay, in this case, well, let's see. Now, your WL is located at the midway. So if you pull rod A, now you look at the bottom right. If you pull rod A towards the directions of WL, what is going to happen to this rod? It will now rotate in the clockwise direction. Okay, imagine you put a nail, kamu paku dia di titik A, and then you pull it towards the directions of WL. Then the rod will rotate in the clockwise direction. So in this case, we say this torque is a negative torque. Okay, this torque is a negative torque. Oh yeah, I made a mistake just now. Your W is pointing downwards, so it should be negative for the Y component. All right. Now, this one is just coincidence, yeah. Quite a lot of students, they like to argue with me. They say, well, now I have a Y positive, my torque positive. I have Y negative, my torque negative. Now, this one is not necessary. Okay, sometimes if you have negative Y, but then you might get a positive torque. Okay, you might get a positive torque, provided if you have the object. Okay, now let's see. Okay, let's see what is going to happen. Now, provided, let's see. Okay, I'm going to remove this one first. Now, let's see if you have a seesaw. All right, the pivot point is located at center. So W on the left-hand side is going downwards. Okay, let's say this is WA, and then this one is WB. Both of them, Y component is negative. But if you try to remove all the other forces and by just looking at one of them, WA will give you anti-clockwise direction. Okay, anti-clockwise direction. Whereas WB will give you clockwise direction. So even though for both of the WA and WB, when it comes to Y component, both of them, they are negative W, But when it comes to torque, WA will give you a positive torque, WB will give you a negative torque. All right. So for this question, the sign convention is just coincidentally same as y-axis. Okay, it doesn't mean that it follows y-axis. Itu adalah salah konsep. Okay, ramai pelajar dia tersalah faham. Dia ingat, okay, disebabkan jadual ini, NB untuk y komponen positif, torque positif. W untuk Y komponen negatif, torque negatif. Jadi saya boleh ikut trend ini. Tidak. Okay. Itu cuma berlaku disebabkan kebetulan sahaja. Alright, kebetulan sahaja. So, contoh yang saya bagi pada anda di sebelah bawah kanan ini, dia menunjukkan bahawa yang tadi punya kebetulan tidak apply pada case itu. Okay, so WA dan WB, when it comes to a Y component, both of them, they are negative. But when it comes to torque, you will have one positive torque, one negative torque. Alright, so jangan salah faham. This one, it happens very often in the exam, where students, because of all this coincidence, then they assume the sign for Y component and torque, they are the same. Well, actually that is wrong. Okay, that is wrong. So jangan salah faham. All right, jangan salah faham. That's why I keep telling you, torque has nothing to do with X and Y component. Okay, so now let's look at the frictions. Okay, friction for Y component is 0, and then how about the torque? So now let's see. Now friction is the friction's force. Okay, so F, and then the distance. Now friction located at point B. Point B is located at 10 meters from point A. So the R is 10. And then sine, now the angle is 53.13 degree. So positive or negative? So imagine, if you remove all of the forces, okay, again, this is the rod, this is point A, you remove all of the forces except friction. So if you pull the rod towards the directions of friction, then what is going to happen? The rod will rotate in the clockwise direction. Therefore, it is a negative torque. Okay, it is a negative torque because if you pull it, then it will rotate in the clockwise direction. All right, so clockwise directions give you negative torque. So that's it. Okay, so these are the informations that we can get from the diagram and from the questions. So now I have a X component, I have Y component, and I have the summations torque. So next, okay, what am I going to do next? I'm going to form 3 equations first based on the table. The first equations would be summations X. Summations Fx is equals to 0. Okay, that is according to this yellow highlighted value. So it is equals to 0, and also because it is equilibrium. So summations Fx equals to 0, I'm going to add up everything along this column. So Na plus negative friction equals to 0. Na is equals to friction. Okay, and we don't have the value, therefore I can say it is also equals to mu Nb. So this is my first equation. Second equations, I'm going to put summations, okay, summations Fy. Summations Fy is equals to 0. So everything's along Y component, I'm going to add them up. So Nb plus negative WL equals to 0. So Nb is equals to WL, which is also equals to mlg, okay, the mass of ladder. So this is my second equations. My third equations would be from torque, okay, would be from the torque. So torque, again, we have summations torque equals to 0. So according to the table, I have Nb times 10 sine 36.87 degree plus negative WL 5 sine 36.87 degree plus negative F times 10 sine 53.13 degree, okay, equals to 0. So this is the information that I have. Okay, so this would be my third equations. So now let's look at the questions again. Okay, you look at your own questions. Okay, I don't want to scroll up again. So determines the horizontal and the vertical forces the floor exerted on NB. So the question is asking for, okay, questions A. Questions A is asking for NB, the values of NB and also friction. Okay, it wants these two values. So what can we do to solve it? Well, we can start from equations number 2. So from equations number 2, we have NB equals to MLG. And the mass of ladder given is 5 kg. So 5 times 9.81, we then have a 49.05 Newton. All right, 49.05 Newton. Then how about questions? Okay, the frictional force. Let's see, can I solve questions for frictional force? Yes, I can. Okay, I can solve the questions for frictional force. So how? Now you look at equations 1. Equations 1 seems like you cannot use it, right? Because you don't have values of NA. Equations 2, well, we use it to determine NB already. So the only choice that we have right now is equations number 3. Okay, so let's use equations number 3 to find the value for frictional force. So from equations number 3, okay, from equations number 3, NB we have 49.05. So 49.05 times 10 sine 36.87 minus WL. WL is equals to NB. Therefore, I have again 49.05, but now it times 5. Okay, times 5 sine 36.87 degree minus friction is an unknown. That is the values that we want to determine. Times 10 sine 53.13 degree equals to 0. So you just rearrange the equations and solve it. Eventually, you will obtain F is equals to 18.39 Newton. Okay, 18.39 Newton. So that is the value. Okay, so now we have the answer already, which is NB and friction. And then questions B. Okay, questions B, it asks you to determine coefficients of friction. So obviously you're going to use F equals to mu NB, right? So F given 18.39 equals to mu NB, we have 49.05. Therefore, mu is then equals to 0.375. Okay, so no unit. Remember, coefficients of friction is just a value without unit. So done. That is how we solve these questions. All right, that is how we solve this question, starting from the table. Okay, starting from the table. So, okay, yeah, that is the complete answer. So I will leave it here for 5 minutes. You can write it down, okay, and then try to take note the important points, the conditions of equilibrium. Make sure to write summations F equals to 0 and summations top equals to 0 because that is part of the concept. Marks will be given in your assignment. Alright, so pastikan Anda catat semua yang penting. Okay, the things that I told you that is important, you need to take note, how to determine the sign conventions and so on. Write down everything.
Madam, kalau soalan macam ni, selalu dalam buku markah 60.
Kalau dalam exam, soalan begini, dia boleh ada dalam 7 atau 8 markah. Tapi sekarang dah tak ada dalam exam, dalam assignment anda. Kalau tak silap saya, soalan ini, soalan untuk equilibrium, static equilibrium, soalan dia satu soalan 20 markah. Okay, total dia 30 markah, satu soalan begini 20 markah sebab dia tanya banyak benda.
Okay.
Okay, so make sure you understand.
Madam,
Yap.
boleh tak Madam terangkan balik macam mana nak tentukan direction of torque tu?
Okay, macam mana nak tentukan directions of torque? Actually, it's very simple. Okay, so kita ambil NB sebagai contoh. So, tengok sebelah kanan. So, this is my pivot point A. Okay, saya ada pivot point A and then saya punya road. So, pivot point, kamu imaginekan ini adalah yang tempat kamu letak paku. Kalau letak paku, dia tak akan bergerak kan? So, NB dia punya arah adalah ke atas. So, kamu bayangkan, kamu sekarang tarik road ini ikut arah NB. So apa yang akan terjadi? Kamu paku dia di hujung A saja. So bila kamu tarik dia ke arah NB, dia akan rotate di anti-clockwise direction. Kalau anti-clockwise bermaksud dia adalah positive torque. Kalau kamu tengok W, okay, kalau kamu tengok W kalau ikutkan free body diagram, dia adalah ke arah bawah. So kalau kamu bayangkan sekarang tak ada NB dah, tak ada force lain. Kamu cuma ada WL. WL ini kalau kamu tarik rod itu ikut arah WL, apa yang akan terjadi? Rod ini dia akan pusing ikut arah clockwise. So di case ini kita ada negative torque. Okay, so kamu bayangkan saja, kamu sekarang ada rod, pivot point itu adalah tempat yang kamu letak paku. Okay, paku yang hidup lah, yang boleh pusing rod ini lagi. And then kamu bayangkan kamu tarik rod itu ikut arah force. Kalau NB kamu tarik ke atas. Kalau WL kamu tarik ke bawah. Dan apa yang akan terjadi pada rod ini? Tengok arah dia rotate. Okay, kamu boleh juga pegang pen. Kamu pegang hujung pen dan hujung pen yang kamu pegang itu, tempat kamu pegang itu adalah point A. Kamu pegang and then kamu cuba bayangkan. Sekarang kamu tarik pen itu ke atas. Okay, so pen kamu dia rotate ikut arah mana? Okay. And then untuk WL, sekarang kamu tarik pen itu ke bawah. Kalau kamu tarik ke bawah, pen itu dia rotate ikut arah mana? So that is how you determine the directions of torque. So boleh tak?
Boleh, thank you madam.
Okay, bagus. Okay, pastikan anda faham soalan ini ya, sebab soalan equilibrium dalam assignment anda markah agak banyak. Okay, markah agak banyak. All right, so next. Okay, so next one, I'm going to discuss exercise 6. Okay, exercise 6, questions number 1 first. All right, questions number 1. Now, questions number 1, exercise 6. Now, in this exercise 6, now actually it's very similar to your Newton's second law. So exercise just now, the example just now is very similar to your Newton first law. Now we're going to look at questions that is similar to your Newton second law. All right, if you recall what happens in Newton's second law, we have summations F equals to ma. Okay, and when it comes to rotations, we use summations torque equals to I alpha. Okay, so this is the first thing about Newton's second law. And then in Newton's second law, we determine the direction based on the sign conventions of A. Okay, we take A, directions A as positive direction. And now when it comes to summations torque, now we are not looking at directions alpha. We are looking at directions of rotation. Okay, directions of rotations as positive direction. Aha. So in a equilibrium, okay, in a just now in a questions in the previous questions, when object is not moving, we take clockwise and anti-clockwise as a method to determine the sign convention. Okay, clockwise negative, anti-clockwise positive. That is for equilibrium. That is for first law. Newton first law, we take right hand side positive, left hand side negative, right? So in a equilibrium, we take clockwise negative, anti-clockwise positive. But when it comes to Newton's second law, we take directions A, directions of motion. To be more precise, directions of motion. The terms. So directions of motion as positive direction. This is when it comes to Newton's second law. So in rotational motions, when we have summation torque equals to I alpha, we take directions of rotation as positive direction. So that is a slight difference between object that is not moving and object that is moving with accelerations and angular acceleration. Okay? So konsep dia ada sedikit berbeza untuk objek yang tidak bergerak dengan objek yang bergerak. Kalau objek tidak bergerak, kita ambil yang sudah ditetapkan punya rules. Okay, kanan positif, kiri negatif, atas positif, bawah negatif, clockwise negatif, anti-clockwise positif. Itu untuk objek tidak bergerak, objek in equilibrium. Now what are we going to look at is object that is moving. Untuk objek yang bergerak, macam mana kita tentukan sign conventions. Okay, so for linear motion, directions of motion, okay, it doesn't matter whether it's going to the left ke, to the right ke, going up ke, going down. Directions of motions is the positive directions. That is for linear motions. Therefore, when it comes to rotational motion, directions of rotation, we take it as positive direction. Okay, so that is the difference between object that is moving and object that is not moving. So force F1, now let's see. Force F1 is 5.6 Newton. Okay, F1 is a 5.6 Newton. And then F2 is 10.3 Newton. So now you have these two forces acting on this wheel, acting on this disc with a 30 cm, and the mass is a 5 kg. So F2 is 10.3 Newton. F1 is 5.6 Newton. So obviously F2 is larger than F1, right? Therefore, this wheel will rotate in the directions of clockwise direction. So when it comes to this case, this is the directions of rotation. So we are going to take clockwise as positive direction in just this question. Okay, directions of rotation. So calculate the net torque under this net torque. So summations torque equals to torque from 1 plus torque from 2. Okay, questions A. So torque from 1, of course, you are going to use F1, but now F1 is going to a direction that is opposed to the directions of rotation. Okay, and this one is a negative. Okay, negative F1R sine theta. Okay, F1R sine theta. Because if you pull the disc in the directions of F1, then it will rotate in the anti-clockwise direction, which is opposed to the directions of the real rotation. Okay, disc ini dia akan rotate di arah clockwise. Kalau kamu bayangkan tak ada F2, cuma F1, kamu tarik dia ke arah F1, dia akan gerak anti-clockwise. So dia bertentangan arah dengan arah yang sebenar. That's why we put a negative sign for torque 1. Okay, the negative sign because it's against the actual, the real directions of motion. So plus F2, now if you push the disc in the directions of F2, it will rotate in a clockwise direction. Therefore, torque 2 is a positive torque. So F2 R sine theta. Now, what is the angles? What is the values of theta? It's very simple. Okay, r is the radius, so it is always perpendicular to the force here. So perpendicular, so it's a 90 degree. Okay, so it is equals to negative 5.6 times with the radius, which is a 0.3 meter, sine 90 degree, plus F2, which is 10.3 Newton times 0.3 sine 90 degree. So total torque here, we have 1.41. Okay, 1.41 Newton meter. Okay, Newton for force, meter for R. So Newton meter. And then questions B, the magnitude. Okay, it just want the magnitudes of angular accelerations. So questions B. Questions B, summations torque equals to I alpha, because now you need the alpha. And then the I is very nice. It gives you the moments of inertia. I for this is half mr squared. So it is equals to 1/2. This m, it refers to the mass of the disc, which is 5 kg. And then r, I have 0.3 square. Oops. Yeah. Let's hang again. Okay. So 0.3 square. And then times with alpha. So torque we have just now 1.41. Okay, 1.41. So rearrange the equations. Eventually you will obtain angular acceleration is equal to 6.27 rad as -2. Okay, radian per second square. So make sure you got the right right unit. Okay, unit will be given 2 marks in your assignment. 2 markah ya untuk unit sahaja, not 1 mark but 2 marks. So make sure you got the right unit in every single questions. So I give you 2 minutes to write it down. Okay, these questions, the important thing is how to determine the sign convention for torque for an object that is moving with angular acceleration. Okay, so idea dia sama dengan chapter 4. Cuma sekarang kita kena ubahkan dia sikit supaya boleh diguna pakai dalam chapter 8. Alright, so that's what I keep telling you guys. Chapter 8 actually is just combinations of chapter 1 until chapter 5. The only difference is in terms of the variables. The concept, the equations, they are exactly the same. The only difference is the symbol. Okay, the only difference is the symbol. So 2 minit bagi anda catat dulu. Yes, any questions? Yep.
Kalau macam yang F2 bigger than F1, so F2 is positive, right?
Sebab sekarang kamu bayangkan kamu nak pusingkan satu benda, dia macam kamu apply force. Okay, kamu apply satu force, satu ke kanan, satu ke kiri. Contohnya yang ke kiri punya adalah 10.3 Newton, ke kanan punya adalah 5.6 Newton. So objek kita of course dia akan bergerak ke kiri kan?
Yeah.
So idea yang sama berlaku di sini. Kita pusingkan disk ini dengan guna force F2 serta force F1. F2 lebih besar daripada F1, maka disk ini dia akan pusing ikut arah F2.
Oh, so dia sama lah kalau macam F1 lebih besar daripada F2, so F1 yang positif, right?
Yes.
Okay.
Kalau dah siap punya, anda boleh tengok soalan ketiga. Okay, you can look at questions number 3 if you are done. All right. Okay, now let's look at questions number 3. Questions number 3 is slightly more complicated. Why? Because it involves both the rotational motions and the linear motions at the same time. Rotational motions is happening at the cylinder. Linear motion is happening at the box. Okay, this box 0.38 kg box. So a solid cylinder of a radius 18 cm. So you have this one. The radius is 18 cm, and it's free to rotate about a smooth horizontal axle. A mass of 0.8 kg hangs from a strings wound around the cylinder as shown in the figure above. When the system is released from rest, okay, the mass takes 2 seconds to fall through a height of 5 meters. What is the moments of inertia of a cylinder? So when it comes to questions like this, okay, there are 3 equations that need to be formed, at least 3. So you are going to see what happens in this cylinder, okay, and now since it's rotating from rest to a certain velocity, then it is undergoing an angular accelerations, okay, angular accelerations, and the mass is dropping in a straight line. So you have a that is going downwards, and then you have a this that is rotating in the clockwise direction. So again, we're going to take clockwise as a positive direction in this question. Oops. Okay, so this is the directions of rotation. So this one you cannot you cannot call it directions of alpha, yeah. Directions of alpha is always perpendicular to the disc. This one you can only mention it as directions of rotation. Alright, jangan guna perkataan yang salah. Kalau kamu kata ini is the directions of alpha, then straight away salah concept. Because alpha is either into the page or out of the page. Okay, you cannot see it in this diagram, right? So now let's see, how are we going to do it now? When it comes to questions like this, first things we need to calculate the torque of the disc. So let's begin with the definitions of torque. So we know torque is equals to Fr sine theta, right? So in this question, the things that we have, the first that we have is tension. Okay, so we have tensions here. So tension for the disc and the tension for the block. So we have tensions, and then the radius given is 18 cm. Therefore, the first equations that I have is a summation torque equals to the force, which is tensions. Now I don't have the value, T. Okay, I'm just going to write down the symbol first. Okay, TR sine theta. But then theta, I can simplify it because it's always 90 degrees for this. Therefore, it is just equals to TR. So this is my equations 1. All right. So let's look at equations number 2. So other than we calculate torque, we also know that this cylinder is moving with angular acceleration. Therefore, let's apply summation torque equals to I alpha as well. Okay. So summation torque equals to I alpha. So I'm going to leave it like this first. Okay. This is my second equations. So if you look at equations 1 and equations 2, what can you say about equations 1 and equations 2? Both of them, they are summations torque. Therefore, I can say equations 1 is equals to equations 2. So TR equals to I alpha. Okay, TR equals to I alpha. Now, if you look at this diagram again, if I keep it as alpha, I cannot link the cylinder and this 0.38 kg mass together. Because 0.38 kg mass, it uses acceleration. In our current equations, we have alpha. Therefore, what can I do? I can say alpha at the same time is equals to RA. A equals to R alpha, sorry. Okay, A equals to R alpha. That is the things that we can use to link linear motions and rotational motions together. So A is equals to R alpha is the most important thing in this type of question. Because without it, without these equations, you cannot link the rotational motions and the linear motions together. All right, the only things that we can use to link them together is accelerations and also tension. So without these two things, you cannot solve these questions. So now let's substitute into equations. So I have TR equals to I A over R. Okay, A over R. So now this R, okay, I rearrange it. I will have I equals to TR square over A. So I'm going to call it my third equation. So done. Okay, this is the part for cylinder. Alright, kita dah siap part untuk cylinder. So this is for cylinder. And then now let's look at the box, okay, the equations for the box. So for box, what can we do? Okay, what can we do about the box? So if you look at this diagram, okay, my box is dropping with an accelerations. So summations F is equals to MA. Okay, so for box, the free body diagram is like this. W and T is going up. So A is going down. All right, this is my free body diagram. So therefore, I'm going to expand the equations becomes W minus T equals to MA. So done. This is the fourth equations. Okay, the fourth equations. But then, do we have enough information to simplify equations 3 and 4 if we want to calculate the moment of inertia? Okay, now we want to calculate the moment of inertia of the cylinder. Do we have enough information? So I equals to TR squared over A. Okay, but then if you look at these questions, we don't have T, we don't have A, right? Kita tak ada T, kita tak ada A, so we cannot determine I. So let's go back to box. Okay, we got T and A in the equations, but then, okay, if you expand these equations furthermore, you will have mg minus T equals to ma. We don't have the values of T and we don't have the value of A as well. Okay, so equations 3 kita ada 3 unknown, which is I, T, A. Equations 4 we have 2 unknown, which is T and A. We don't have enough information to solve it. So let us go back to this statement. There's a reason why the questions give you this statement. When the system released from rest, the mass takes 2 seconds to fall through a height of a 5 meter. So this statement itself, it gives us U equals to 0 ms negative 1 times equals to 2 seconds, and the height equals to 5 meter. Oops, that is your height is S. Okay, height is S. Now it falls 5 meters, so it is negative 5 meter. Okay, because it's dropping. The position is below the original positions. All right, it is below the original positions. So what are we going to do right now here? Well, let's see. So S equals to UT plus 1 over 2 AT squared. All right, UT equals to 1 over 2 AT squared. So now my A is going downwards. So what I have right now, let's see. S is a negative 5 equals to 0 minus, okay, or minus 1 over 2 A 2 second. Okay, now I put a negative here because my A is going downwards. Okay, because my A is going downwards according to the diagram. So in these equations of linear motion, we still stick to upwards positive, downwards negative. Okay, kita masih kekal. So now your object is accelerate in the negative direction. Therefore, my A is a negative value. All right, so negative cancel out. I have 5 equals to 1 over 2A 2 squared. So my A is now equals to 2 ms negative 2. All right. So when it comes to the motions of linear motion, the equations of linear motion, kita masih kekal. Atas positif, bawah negatif. Kanan positif, kiri negatif. Right? So now that you have A, you can then calculate T. Okay, go back to equations number 4. So ini step, kita sekarang ke sini. So M for the box is 0.38. G is 9.81 minus T equals to 0.38 times 2.5, bukan 2. Okay, 2.5. So 2.5. Okay, 2.5. Then T is equals to 2.78 Newton. All right, 2.78 Newton. So once you have it, you can then substitute into equations of I to calculate the moments of inertia. All right. So step 1. Okay. Step number 1. Okay. Step number 1. Step number 2. Alright. And then sekarang kita pergi ke last step, I. So I is then equals to 2.78 times with the radius. The radius of this cylinder is 18 cm. So 0.1 x squared divided by A, which is 2.5. So therefore, the final answer is 3.6 times 10 to the power of negative 2 kgm squared. Okay, kgm squared. So this is the informations. This is the things that we do to solve this questions number 3. All right, questions number 3 is also a good questions that shows you how to solve equations that involve linear motions at rotation and rotational motions at the same time. Okay, so bolehlah kamu siapkan dia sekarang. Okay, now you finish it. If you have any questions, you may ask. If no, that's all for today and you may leave the class. So we are done with chapter 8. All right.